Hi, welcome to Expertisor Academy. This is Giri, lecturer in physics. In this video, we'll discuss about the interference. In this video, we discuss the interference topic. The phenomena of addition or superposition of two light waves, which produces increase in intensity at some points and decrease in intensity at some other points, is called interference. So, what is the definition of interference? The increase in intensity, that region, decrease in intensity, that is another region, or different points, are formed by the superposition of two light waves. So that is interference of light. Simply, the light rays are superimposed each other. The light rays are superposition or added with each other produces the increase in intensity or higher intensity at some points, decrease in intensity, that means lower intensity at another points. So this process is called the interference of light. So let's verify the interference with the diagrammatically and then theoretically. Let us consider two light waves from the two sources S1 and S2 meeting at a point P as shown in this figure. Let us consider two light waves S1 and S2 are coming from the two light sources S1, S2. So these two light waves are superimposed at point P. The wave from S1 at an instant t at P is y1 is equal to a1 sin omega t. So y1 is equal to a1 sin omega t. The waveform S2 at an instant t at P is y2 is equal to a2 sin omega t plus 1. The two waves have different amplitudes a1 and a2, same angular frequency, that is omega, and a phase difference of pi between them. The resultant displacement will be given by y is equal to y1 plus y2, that is equal to a1 sin omega t plus a2 sin omega t plus pi. So after getting this, Simplification of our equation by using trigonometric identities as done. Y is equal to a sin omega t plus theta. Y is equal to a sin omega t plus theta. Where a is equal to square root of a1 square plus a2 square plus 2 a1 a2 cos phi. Capital A is equal to square root of a1 square plus a2 square plus 2 a1 a2 cos phi. So therefore theta is equal to tan inverse of a2 sin phi divided by a1 plus a2 cos phi. So theta is equal to tan inverse of a2 sin phi divided by a1 plus a2 cos phi. The resultant amplitude is maximum. The resultant amplitude is maximum. The maximum amplitude that is equal to square root of a1 plus a2 whole square when phi is equal to 0, plus or minus 2 pi plus or minus 4 pi. The resultant amplitude is minimum. Amplitude is minimum that is equal to square root of a1 minus a2 whole square when phi is equal to plus or minus pi plus or minus 3 pi plus or minus 5 pi. The intensity of light is proportional to square of amplitude. So intensity of light is directly proportional to the square of the amplitude. Now this equation is converts into I is proportional to I1 plus I2 plus 2 into square root of I1 I2 cos phi. The equation, if the phase difference phi is equal to 0 plus or minus 2 pi plus or minus 4 pi, it corresponds to the condition for maximum intensity of light called as constructive interference. So there is a maximum intensity, so that interference is called constructive interference. The resultant maximum intensity is the resultant maximum intensity is I maximum is directly proportional to A1 plus A2 whole square is proportional to I1 plus I2 plus 2 into square root of I1 I2. In equation I is proportional to I1 plus I2 plus 2 into square root of I1 I2 cos phi. So here it corresponds to the condition for minimum intensity of light called destructive interference. Destructive interference. The resultant minimum intensity is proportional to A1 minus A2 whole square is proportional to A1 plus I2 minus 2 square root of I1 I2. As a special case, if A1 is equal to A2 that is equal to A, then we get the amplitude square root of 2A square 2 cos square pi by 2. It gives the result A is equal to 2A cos phi by 2. So I is proportional to 4A square cos square pi by 2. So I is equal to 4I naught cos square pi by 2. So finally maximum intensity is equal to 4I naught. So here theta is equal to 0 plus or minus 2 pi plus or minus 4 pi like that. So I minimum that is equal to 0 when phi is equal to plus or minus 5 plus or minus 3 pi plus or minus 5 pi. We conclude that the phase difference phi between the two waves decides the intensity of light at that point where the two waves meet. So this is the information about the interference. So here interference is converted into two types, constructive and destructive. So thanks for watching this video. For more videos visit www.expertisoracademy.com. Thank you.